Hi, everybody. This is Carl Freund with Cambrian-AI Research, and today I have the CEO and founder of Esperanto. Now, I've written a little bit about Esperanto because I think it's very exciting on two fronts. One, the emergence of RISC-V as a viable platform for data center applications, but also the energy efficiency of doing so. Well, Art, welcome to the program.
Well, thank you very much, Carl. Appreciate it. Glad to be here. It's nice to connect with an old friend.
Yeah, likewise. We've been through a lot together, and I'm very excited about what's happening with Esperanto and RISC-V right now. I mean, you guys have a chip with over 1,000 RISC-V cores in it, right? Why don't you just start with company update? What's going on, and what are you excited about?
Well, sure. So, like you, we're very excited about RISC-V. You know, we've been with RISC-V from the beginning. We were a founding member of the consortia. And of course, our CTO and co-founder, Dave Ditzel, is one of the original progenitors of RISC with his seminal paper that he wrote with Dave Patterson, you know, the case for reduced instruction set computing back in the early 80s. So we've been RISC advocates from the very beginning, and RISC-V, you know, since the start, since it rolled out of Berkeley. Now, the really great thing is the momentum of RISC-V is just increasing dramatically. You know, a few years ago, you saw RISC-V cores used in, you know, embedded devices and so on, and then gradually moving up the food chain. But now, really with accelerator chips like ours and server class RISC-V chips coming out for hosting, you know, Linux and other applications, it's really powerful. The momentum's growing, ecosystem's growing. So it's pretty exciting that we're at the forefront of that. And then, as you know, the 1,000+ cores that we have on our chip, that's really a tough thing to achieve. It requires extreme energy efficiency in order to get, you know, that kind of computing power onto such a low power device. We target 20 watts as our key chip power. And so that's a real engineering feat, and it's kind of the expertise of the company. And I think, you know, we've proven that it certainly can be done. We're shipping products based on those RISC-V accelerator chips around the world. We have not only the chips themselves, but PCIe cards and servers going out the door. So really an exciting time for us. Plus the new applications that are coming out, generative AI and large language models, have just put the afterburner on in the AI market. So suddenly every consumer knows what AI is, or at least they think they do, because of ChatGPT. But we have a little bit different take on that. I'll be happy to talk about with you. It's we think the real excitement is going to be in applying large language models, not in a horizontal way, but for vertical markets where they're really going to pay off big.
Well, let's talk more about that, because obviously everybody thinks they know a lot about generative AI, whether they do or not. But it's top of mind for customers and investors and researchers. So let's dive into that a little more. What are you doing with generative AI? What kind of results are you seeing? And talk a little bit more about this vertical approach you're taking.
Yeah, well, if you just go back to the technology approach first, remember we have all these cores. They're multi-threaded cores, and we also have the capability to run Linux on our, or any operating system, frankly, on our devices with our bigger cores. So what we think is happening or will happen is that this great horizontal technology, the ability to, you know, go from speech to image to anything, you know, to coding to whatever, that can be applied in really key verticals. Now, our architecture lends itself really well to this because we have lots of processing, we have lots of threads and lots of cores, and also we have a lot of memory on our chip. And then we have a lot of memory on our cards. So large language models like generative AI require lots of not only processing power, but lots of memory. And so we're well positioned for that. Now, why we think verticals are the right way to go. You know, we think that there's something that's a little bit of a downside in the current generative AI approach, that the training of the data sets and the limitations of the data sets, the proprietary nature of those data sets, means that it's only the biggest companies that have access to, you know, the fully trained models and data sets. But what about applications where you don't want to give up your data set or have it out there in the public domain? What about the entertainment industry or the medical industry or, frankly, enterprise computing? Do we want all those data sets and all the trained materials out in the public domain and only being available in the cloud with the biggest cloud service providers? No. So we think that there's privacy reasons, there's proprietary nature of protecting your IP reasons. So many reasons for different verticals that are going to require localized generative AI and specifically targeted for their application. So think about the entertainment industry, for instance. Certainly, the guys who are making movies don't want their data out there in the marketplace in the public domain, nor do they want to expose their entire film libraries out there in the public domain. So this is a really neat application for us. Also, there's one other factor. The energy efficiency comes to play here as well. I'm sure you've seen the studies that say, today 1% of the energy usage in the world is in, hyperscale data centers and major data centers. Well, recent studies have come out that said, generative AI is going to require 5 times as much energy usage, for instance, if it's incorporated in search, as today. And that's simply not scalable. I mean, think about the implications of that from a carbon footprint point of view. So having energy efficiency to underpin all of that with highly efficient accelerators like ours running at circa 20 watts, that's an incredible change. So again, we think the verticals are super exciting. ChatGPT brings it into the fore for consumers so they have an idea of what's happening. And of course, the data scientists, the research is happening at an incredible breakneck pace. So all exciting trends. The changes are also good for us because we have a general purpose processing architecture, just like traditional, frankly, vector supercomputers of the past that people know how to program. And so it's a much easier programming paradigm to write code for our accelerators than, for instance, some of the other ones that are out there in the marketplace. Anyway, lots of exciting things in that area.
That's cool. That's cool. So when you talk about vertical approach to generative AI, am I correct in assuming that it also would rely on smaller models that more easily fit into your architecture?
Yeah, that's a great point. We're a big believer in moving out of the cloud and toward the edge. And so our devices are really well suited for generative AI applications at the edge. So again, these are intended not to be in water-cooled beast products, but things that could actually show up on-prem or on-premises in different applications. And so part of our strategy is to use the larger cores that we have on our larger RISC-V cores on our chip to run Linux and self-host. So if you think about it, typically in a data center, an accelerator sits next to a Xeon processor, an AMD processor, and then that the host is offloading a task to the accelerator chip. Well, our chip can self-host, which means that you could eliminate that expensive Xeon or AMD processor and run the operating system on our side and then the accelerator on the same chip. The cost reduction potential, the total TCO, is going to be vastly better in our devices. And so it's a real push to the edge. Some people like to talk about the democratization of AI. And I think it's true. This really, for generative AI, having lower cost edge devices that, don't require massive data centers to run, I think it does open up a lot of doors for people, certainly for researchers, for retailers, any number of applications.
Mm-hmm. Yeah, I mean, I think we've all seen this coming where accelerators have enough, general purpose processors on them, like RISC-V, that can actually run the operating system and farm out the work to acceleration to smaller cores, kind of like the old ARM big little idea, right, for desktops, where the main CPU is running the OS and other cores are doing things like handling keyboard interaction, things like that. It's kind of an evolution of that concept, isn't it?
Yeah, and absolutely, Carl. And with your background and history, ARM server chips started coming into the fore, 10 years ago, the real efforts, or maybe a little more, started, and people have finally embraced ARM servers. Seems to me that the RISC-V is just starting at that point. The first really capable RISC-V server chips are coming out, and that's going to be a dramatic change. But in this case, what we'll see is RISC-V tied to RISC-V. So instead of x86 with an accelerator or ARM with accelerators, we're going to see RISC-V and RISC-V. So really, this is a key time. I think it's a pivot point for the RISC-V industry. This is finally the point where the ecosystem is there for RISC-V to penetrate the data center. And frankly, we expect to be one of the first into real data centers with RISC-V chips.
You certainly seem to have a considerable lead over any other contenders right now in terms of developing or delivering RISC-V that's capable for the data center. But the application space, software stack, I mean, when I was at Calzada, we had no idea it would take 10 years before we'd see an ARM-based CPU in the data center, which we have now. There's some good products out there today on ARM, but it took 10 years almost for the software to get ported and tested and tuned and so forth. Does RISC-V kind of follow in that wake and say, well, you've already eliminated your x86 dependencies? Is the porting job that much easier now because of the incredible effort of the industry to get ready for ARM?
Well, it's so funny, Carl, because you may not have heard me at public talks, but early on, I was vice president or vice chair of marketing for RISC-V for the consortium. And people would ask me, how long do you think it will take for the ecosystem to fully develop? And I said, it's a 10-year process. But this was, 7, 8 years ago.
Yeah.
Definitely, it's a journey. It started out in the embedded space where, there's a narrow set of applications. Greenfield applications like AI were relatively easy because there was no, incumbent software stack that we had to address. And we just embraced the open source Glow stack from Meta that they open sourced. Gradually, these new applications come on, that the more capable processors come out. But the key is just the vibrant ecosystem. The number of developers that are out there who are building on RISC-V, I think, is accelerating that. Now, the question will be, ultimate question is, can RISC-V displace ARM in mobile applications? And certainly we see the beginning signs of that. There's, as you well know, there's industry initiatives to port key applications onto RISC-V that are showing some promise. Data centers, I think, is right there in the very near future with the extremely capable data center class server chips that are coming out with accelerators like ours. I see lots and lots of work on the required ecosystem. It's the same kind of stuff that Calzada had to do 10 years ago, but I think it's happening fast in the RISC-V space.
Mm-hmm. Sure seems to be. So let's wrap up by talking about other application areas. We've talked about AI. You've definitely seen traction as European data centers and those elsewhere in the world say, RISC-V might be a much more energy efficient approach without some of the encumbrance of the ARM licensing that has been widely reported on lately. What other application areas besides AI and HPC do you see as ripe for moving to RISC-V?
Well, it's really interesting. Just commenting on the HPC area, there's something that's driving that as well, which is the mixture of AI and HPC in a single application. So even in supercomputers, we're seeing that there's a merger of those requirements. And so we think that's a key trend, that these two technologies are blending. And it's a rare chip, we think, that can be used effectively for both applications at the same time in the same system. And that's kind of our goal. We call it mixed mode or hybrid process. So as far as RISC-V goes, I think you're going to see RISC-V everywhere over time, Carl. I mean, if you just look at the number of companies who are engaged, the degree of enthusiasm when you go to a RISC-V conference, sold out conferences, hundreds and hundreds and hundreds and hundreds of students and so on. It's being taught in every university in the world now. And so it's a wave that is approaching its peak. It's really coming hard. And so the degree of applications will be everything from the smallest devices, in-car devices, retail, camera, you name it, all the way up through from, as we say, from cloud to edge. So, or edge to cloud. So it's going to be everywhere.
Exciting place to be right now. That's for sure. I've always said that with I wrote a paper about, I don't know, 6 or 7 years ago. One of my first papers was about the convergence of AI and HPC. And what I posited at that paper was, yeah, it was, I guess so. Well, I had some friends at NVIDIA that was they were kind of leading me along. So, and they were absolutely right. The fastest, the most cost-effective simulation you can ever run is the one you don't run. It's the one you estimate. And you estimate it through machine learning based on all the thousands of runs you've done from different starting conditions in the past. Great, that's a great labeled data set. Let's run it through a neural network and estimate what a different set of starting conditions would produce. And boy, I tell you, the scientists around the world just jumped on that concept big time. And I think you guys are well positioned to take advantage of that trend and others. I'm sorry, go ahead.
Well, Carl, I just wanted to add on to what you're saying. The scientific community has always been the ones who are pulling along the HPC applications. And what I found that's always ironic is some of the most conservative organizations in the world then have to embrace the technology that they want to use. And so what I'm loving right now is seeing these big organizations that are very conservative embracing the new technology RISC-V. So the scientists, the data scientists are driving it, but the organizations are latching on. So I think you were prescient when you wrote this combination of HPC and AI, and RISC-V is coming.
Yeah, I think so. Well, the world prefers open, right? In spite of the recent trend in AI to go closed, it's like somebody told me once there's a big pile of money on the table, people stop being so open and friendly and sharing all their code and their models. I think, I don't know, will that swing back to being open at some point? I mean,
oh yeah, I absolutely believe it, because one, the data scientists all need to have access to open models so we can all innovate together. I mean, that's the beauty of RISC-V, right? It's open platform that everybody can innovate on. It's like the platform for innovation. And the same with opening up the AI models and data sets. But again, some may remain proprietary just for confidentiality reasons or data privacy reasons or whatever. And so what we need to do is deliver AI technology that can run in those smaller environments as opposed to in a giant data center, so that enterprises can protect their proprietary data or their customers' private information. So definitely there's going to be a mix of openness for development, but some closed aspects for proprietary applications. So I think it'll be a mix.
wow. Well, we're certainly entering a new era in AI and HPC. And with the advent of competitive RISC-V SoCs, I mean, 1,000 cores for 20 watts. I mean, this is just blows me away what you guys are able to do.
Yeah, thanks. The legacy of the company is not only just in RISC, but also in energy efficiency. Ditzel, when he joined Sun, he was part of Sun Labs, and he had a many-year focus on energy efficient design techniques. Really a pioneer in that area as well. Then, of course, Dave founded the famous company Transmeta. I joined him there. We worked together on the energy efficient x86s, which were unheard of at that time. There was no such thing. And, frankly, we outpaced Intel getting the low power mobile devices to market first. We pioneered the first blade servers, the first tablet computers, and the first thin light notebooks of that era. And again, that energy efficiency was at the core of that design. And then once again, we bring key members of that team together here at Esperanto to do the same thing in AI acceleration and HPC chips. So,
yeah, you've managed to build a company of some of the best experts in the world in energy efficient processing. So I think the prospects look bright to me anyway, that you guys are in the lead with RISC-V. You're in the lead with delivering product, not just PowerPoint slides. And so my congratulations to you and the team. Please give Dave my warmest regards. And Thank you very much for your time today, Art. I look forward to doing this again soon with you. Maybe once you kind of stand up your first couple of supercomputers, which I expect you will. We can do this again, if not sooner.
Well, I look forward to that, Carl. Thanks very much for your time as well.
Thank you, Art. Take care. Have a great week. Bye-bye.
Bye-bye.